Are we starting? Oh, yes, we are. All right, everyone. It's August 14th. All right, I'll take a look here. Oh, thanks. All right, nothing of concern. All right, let's do this. Remove boxes.
Ask Joe.
Wow, it's so short.
Ask Joe.
Ask Joe.
Joe.
Joel. The name that the name that I hear different Brazilians say it differently. They don't even know how to pronounce it. It's a difficult name to pronounce. Anyway, so remove boxes. You're given several boxes with different colors, represented by different positive numbers. You may experience several rounds to remove boxes until there is no box left. Each time you can choose some continuous boxes with the same color, composed of K boxes. Remove them and get K times K points. Return the maximum points you can get. So you can do several rounds. That's a very weird way of saying you may experience several rounds to remove boxes. I don't know who wrote this. You can remove several rounds, right? And each round you can choose some continuous boxes with the same color. So it has to be continuous. Remove them and get K times K points. Return the maximum points you can get. Here's the boxes. Okay. We remove 3. Wait, what? Oh, K boxes, remove the number. So we remove 2. Alright, that gives us 9 points. And then we remove 4, that gives us 1 point. Remove 3 again, give us 9 points. And then remove 2, give us 4 points. This we can remove all 3 at the same time. Interesting. So these are just colors. It doesn't really matter. Alright, so we need a strategy to remove boxes. I mean, apparently it's now greedy, because this already shows greedy doesn't work. Greedy will be we remove the longest continuous, and here we'll be removing this as the longest continuous. So it's now greedy. I mean, it's most likely dynamic programming, and we just need to find the relations in dynamic programming. All right, dynamic programming, we always drill down to the simplest case, right? If we have one color, we just remove it and give it 1 point. If we have 2 colors, of 2 boxes, any number of boxes, if we're given, they are of the same. Any remaining box, if they're of the same color, we always remove them at the same time. That is something. Is it? If I have K boxes, we remove it at the same time, we generate K times K. If we're removing 2 rounds, it's something, let's say A squared plus, we can actually prove this, A squared plus K minus A squared. That's like we break it down into 2 rounds. So if we expand it, we get K squared plus 2A squared minus 2KA. To compare this with K squared, which one is larger? Well, I think we can just do K squared plus 2A squared minus 2KA. That is if we do it 2 rounds, right? We do 2 rounds. One round take A, the other round take K minus A. And then that's the score we get. If we do that minus K squared, we'll get 2A squared minus 2KA. If it's larger than 0, right? If it's larger than 0, it means it's better to do it in 2 rounds instead of 1 round. and we get 2a out, a minus k larger than 0, and we get a is larger than k, which means the only possibility is when a is larger than k, but a is not larger than k, a is smaller than k. So it is always good, always better to take, if you have k boxes remaining and they're all of the same color, the best strategy is to take all of them at once. So we got that one, right? Okay, so that's one color. We have one color. We have solved it. Now if we have two colors, right, that's we're starting to have different things, and then two colors, and we have mix and match. Let's say two colors, they are two boxes, and each one different color, and the only way is to take each one by itself, right? And if we have continuous, one color continuous and the other color continuous, and that's the same, because if you can, right, here's the thing, what I think is if all the colors remaining are continuous, then we take all of them, right? So that's also like if you have 1, 1, 1, 2, 2, 2, 3, 3, 3, it's very simple. We take all ones, take all twos, and take all threes. Boom, we're done, right? So that is the easy part. The difficult part is when we start to have mix and match, right? So let's say we have 1, 1, 2, and then 1, right? So 1, 1, 2, 1. Apparently, the best strategy is that we take 2 first, and then we take 1, 1, 1. Right? That's the best strategy. How do we formalize this? So that's like two colors. It's actually just 1, 2, 1, right? 1, 2, 1. If we take each one by itself, it's gonna be 1 plus 1 plus 1. But if we take 2 out first, that's 1, and a 1, 1 take together, that's 4. That's 5 points, right? That's more than take each one by itself. So does that mean if we have values separated by others? Yes, that does mean that. Say we have boxes of the same color, and then they got separated by, like there are other things jammed inside, in between them. Like this case, we have 3, 3, right? 3 and a 3 and a 3. We have 3 threes, right? And we know the best strategy to get all the threes is to combine them together, because combining together give us more points compared to take each 3 by itself. So to combine them together, we need to take all the 2's, right? Take all the 2's out, and then we end up with this, right? And then we need to take the 4 out. Okay, so that situation is also explained, right? Because it's the same. Like we have 3 threes. If we take 2 rounds, take 2 3 and a single 3, or we take 3 rounds, and that will end up with fewer points compared to if we take them all at the same time. So we should always aim for taking the colors of the same color. We'll wait until they become continuous. Now this is an easy case. Now the difficult case is, let's say we have 3 3. We'll have 3 3 4 3 3 3 4 3 4, right? So if we have 3 3 4 3 4, we actually examine how that one look like. If we have 3 3 4 3 4, right? That's an interesting case. It's just gonna return 0. I don't know what the result will be, but we can analyze it first. So in our sense, both the 3's and the 4's, they are separated by each other. Right? So we don't know which one to take. I mean, for here, 4 is all by itself, right? So we can always take 4. Like if we have any value, any color that's by itself, then we just take it. I mean, there's no other way to do it. And we have any values that's already in continuous shape, like the 2's, we always take it. So we remove all of those, and the remainings will be the colors that are intersected with each other. And if you can see here, 2 to 2 taken away, 4 taken away, we end up with this shape. This is a good shape, right? So we have 1 and 3 that's separated, and what we see is, no, 3 is actually not separated, so we can actually keep taking. We take 3 and then take 1, so this is an easy case. But this one, maybe we need to make a choice, right? So we can either take this 3, such that if we take this 3, then we can combine the 4s, right? And then, so we're going to end up with 1 point taking the 3, and 4 point taking the 4s, and then 4 point taking the 3s. So that ends up with 9 points. If we take the 4 first, that's 1 point, and then we have to take another 4 by itself, and then we take for the 3s. That gives us 11 points, right? So, does that mean if they're intertwined, so we always aim at combining the longest? Does that give us more? That give us more advantage? I feel like I'm analyzing it. It's not like really computing it. Let me think. Maybe we can like do a comparison, right? I mean, we definitely are going to, how do we even know they're intertwined? We take 4. So in this situation, I think it should be 11. Let's just see if it's 11. Yep, it is 11. So what do we say? We say, like, we know there are 3 3s and 2 4s, right? That's what we know. We know there are 3 3s and 2 4s. 3 3s and 2 4s. And we know their positions. So let's say we're always trying to get the largest, all right? Let's say we want to get the 3 3s to combine. And they're not combining because we have a 4 jammed in between. Okay, so now we want to remove the things that's jammed in between. There could be multiple things jammed in between if you think about it. If we have other values. I feel like I shouldn't be analyzing it. I mean, there's like a loss, right? Because when we are trying to get 3 3 together during the path, we are losing on other things, right? We're losing. We have to do 4 2 times, right? So 2 rounds to get 4, which give us 2 points. If we do 1 round of 4, that's going to give us 4 points. But here's the situation, right? We will have to do one number after combine. If we take all the numbers without combining them, then we will be at a loss for sure. Right? If we take all the numbers if we do not combine numbers, we take it as is. Then we take it as is. with no effort to combine, then we're gonna lose points with the longest. So that's for sure, right? That is for sure. Maybe it's a tree. It's a search, right? So we have, we already removed all the numbers that's already in a row, all the colors already in a row. We remove all the single ones, so the ones remaining are being separated, right? So we can count how many numbers there are, right? And then we just do one by one, right? We do one by one. Let's say, greedy will be, we always aim to get the longest to combine, right? That's the greedy part. We want to get the longest to combine. How do we remove the rest? Let's say if we want to get 333 to combine, then we need to, then if we want to get 333 to combine, then this is in itself, right? This part is in itself, and we can analyze it by itself. And we have other things inside, and then they're all separative, right? We cannot remove them. So within this, 4 is by itself, right? 4 is by itself, so we can get it. So we know in this situation, 4 is by itself, and then other things might be by itself, so we can just remove them as is. And when they remove, we remove this, and then we handle the remaining. Right? That's like we do 333. And we can also do all the other situations, right? We can do all the 4s. We have other things, like, and we can compare, right? So basically, we can iterate through all situations, and then try to see if it's worth the effort, right? Most likely, I think it's not going to be worth the effort. But there might be an edge case that combining the longest might not be the ideal situation, especially if the two longest has similar. Anyway, now we find the one with the longest, right? We find the one with the longest. Find the one with the longest. And then we isolate that part of the array, and we try to remove the remaining. How do we remove the remaining? So we look into that part. I just take that part out and we'll look into it. All right, we'll look into it, and we'll find the one that's by themselves. We can copy it. I can copy it to make it a little bit simpler, because we only have 100 in length, so we can afford to go a little bit, costly on the algorithm. All right. Yeah, I'm still thinking if it's the optimal solution. I mean, for sure, if you have, like, say, 2 mixed with, like, 98 others are all the same, and you have 2, it's kind of mixed in between. And you definitely will not say that, well, keep the 2 and then we discard the remaining. Right? I mean, there is a certain, I kind of feel this is going to be, if we can prove, right? If we can prove that in the situation of mixing, from mixed situation with one value, let's say we have n, one color we have n boxes, and the other color have n minus 1 boxes. So they're very close, right? They're very close because the farther away, like if we can prove n and n minus 1, it is better to do n than to do n minus 1. Then it can be generalized to all the other situations. So let's try it. If n and n minus 1, right? So let's say we want to focus on doing n instead of n minus 1. Actually, we should do the other way around just to prove the contradictory. So let's say if we focus on n minus 1, right, we want to get n minus 1. And then if we want to do n minus 1, so whatever they are mixed, so whatever type of things they're mixed, then we need to remove the others, right? Remove the others. And let's say when we remove the others, okay, let's do it again. Let's do n, right? So we want to combine the n together. So we need to remove the n minus 1 without grouping them. So what is the maximum score we can get by removing n minus 1, right? If we find a maximum by doing this, is still not going to be, no, not maximum, the minimum. So we have n, right? We have n we want to combine, and we have n minus 1 that we cannot combine. What is the minimum score we can get by removing n minus 1 and then combining n? So we calculate that score. So this is like the minimum you can get by combining n. And then we compare that to combining n minus 1, and we get a maximum you can get by doing n. And then we want to see, okay, yeah, we do a comparison. So we have n values, right? And then I think the best illustration, let's just use 3 and 4, right? So let's say we have n 3s and n minus 1 4s. So the worst situation to combining 3 is this, right? 3 4 3 4 3 4 3 4. That's it, right? So the n values, they are intersect by n minus 1 values. So if we want to combine all the 3s, we're going to take out all the 4s, and each 4 is by itself. So we get n minus 1 point, right? We get n minus 1 point, and after we get that, we get n squared point. So we get n squared plus n minus 1. So that is the combining n. Okay, that's the worst case. So what is the best case with combining n minus 1? So the best case of combining n minus 1 is when the n is all combined already, right? Except for the last one, right? Otherwise, we can take the n by itself. So we're gonna go 4, so it's kind of jammed in between, and I mean the remaining 4s doesn't really matter. So but it does matter. So this is the situation where the n minus 1, which is the color 4, if we combine n minus 1, we can get a maximum value because we have these all combined, right? So this we're going to get n minus 1 squared, right? N minus 1 squared plus n minus 1 squared. So 2 times n minus 1 squared. And then plus 1. I feel this is actually larger. I do think this one is larger. This is what? 2n squared plus a minus 4n plus 2 plus 1. So plus 3. Alright? So this is combining the smaller one first. And then that's combine n squared plus n minus 1. That's combining n. And just by looking at it, it does seem to be. Let's do it. So let's say n squared plus n minus 1 minus. Let's do the other way. Let's do 2n squared minus 4n plus 3. This is this situation, right? Minus n squared plus n minus 1, which is the worst situation of combining n. what do we have when we do this? When we do this, what we have is n squared, right, minus 5n plus 4. Right, this one is n minus 1 times n minus 4. So if this is larger than 0, that means doing this is better. And specifically in this situation, right? Specifically in this situation. What it gives us is n cannot be minus, so n has to, if n is larger than 4, if n is larger than 4, then this one actually gives us more points. Yeah, this one actually gives us more points by combining, by taking this. All right, so it'll be 9, 8, it'll be 19. This one probably gives us 19. And then if we do, no, this one gives us 21, which means, yeah, it's still easier to take this out. I think the analysis is not right. Like in this situation, it's definitely take 4 out to get all the 3's. That gives us 16. All right, 16 plus 1, 17 plus 4. What was my analysis? Oh, the analysis is the best case scenario of combining n minus 1. But in this scenario, we're still not combining n minus 1. We're still combining n. Like in all scenarios, we're combining n. I mean, we shall do, hold on, so let me do it again. If we do 3, 4, 3, 4, 3, 4, 3, and end up with 3, right? So this will give us n squared plus n minus 1. That if we do combining n, if we're not combining n, we're combining n minus 1, that gives us n plus n minus 1 squared. So it's n squared minus 2n plus 1. So give us n squared minus n plus 1. All right? And then the two things, if we minus, right, if n squared minus n plus 1 minus n squared minus n plus 1, what do we get? We get 2 minus 2n. If it's larger than 0, n has to be smaller than 1. But n cannot be smaller than 1 because if n is smaller than 1, and n is 0. So in all situations, it's going to be more combining. Yeah, so this, I think, so this is a situation where combining for n is the worst case. All right, combining for n is the worst case. We gain the least. In all the other situations, we always have n squared plus something, right? Because we have some type of combine in others, and the rest we have to plug them out by itself. And if we do the other way around, then we'll have n minus 1 squared. And then the other way we'll do. So I think in all situations, in all combinations, it's always a better strategy to combine because see in this situation, basically just move 4, right? We'll move 4 here, and then this one is better to move 4 because they'll be combined together. And then we do this. And then another way is we move this 4, like we jammed in between. What are we trying to prove? That'll be the same. That'll be the same. And no matter what we do, we're picking apart the remainings, right? We're picking apart the remainings. Otherwise, we're going to picking apart on the big ones. Huh. Yeah, what we should say is this is the best scenario for combining the smaller one, the smaller sides. And the best scenario combining the smaller sides, which give us 19, by the way, is still smaller than combining the big side. So all the other situations shall be a no-brainer, right? Yeah, this is the best situation to combine the smaller sides. And all the other situations, if we want to combine the smaller sides, we will get less out of it. So I do think, I don't think I have a full proof yet, but I feel it shall be this way. We find the ones with the largest, right? We find the ones with the most occurrence, and then we remove the things from within, and then we remove that as well, and then we handle the rest. Yeah, that is our strategy, okay? So the strategy is straightforward. Given these numbers, any numbers, first task, we remove all the ones that are singles. So we do a counter, right? Not a counter, we do a dictionary that will record. We'll record their indices, right? We'll record their indices. So we taken away the values that they're indices. So when we get it, any values that has a single count, those are gone, right? Those immediately gone. Any values that are continuous, that means we have the count of that color, and then the indices indicates that all those counts are continuous. Those are gone as well. So we do that, both are gone. For the remaining, right? For the remaining values, we will rewrite them. Rewrite based on their indices. How do we do that? How do we rewrite them? I don't think we can rewrite, but what we can do is we can mark, because the values are all positive. So we mark the boxes as zeros, right? And so like 4 is gone, so we put a 0 here. 2 gone, we put a 0 here. And then we will reiterate through the entire thing, put the numbers out, skip the zeros. That's when we combine them into a new array. And then when we get the new array, we basically find, right? We know which one is the longest, right? We know which one is longest. Well, actually, when we get that, when we get the new array, shouldn't we run that again? Yeah, we should run like a loop, right? We get a new array and we go to it again. And in this case, we have something that already is grouped together. So the decision is linear, right? We don't need to have other considerations until we cannot do it anymore. So now we're ending up with something like this, right? There's no single color that's continuous. There's no individual colors. When that happens, right? When that happens, what we do is we will find the color that has the most count. Right? We'll find the color that has the most count, and we will know its indices. Right? We'll know its indices. We'll know its indices, and we are going to take that out, right? Take that out. We're gonna make a copy of that, and we run on that. The same algorithm run on that, and the same algorithm run on the other parts. So we always split into two parts, right? The one part is the colors of the most number of boxes of the same color, and then the other parts. So we run on both.
Does this look like 1/3?
Yeah, so you just go, whoosh, whoosh. These will be mine, the rest go.
This is 1/3?
Yeah, there's one there. You cook very good rice. Looks delicious. I'm gonna try. It seems like reasonable to me, but I am not sure. But we are going to try. If it doesn't work, we can check the answers. I feel like I have exhausted my options. Okay, so here what we do. Well, we're gonna first just create things, right? So we're gonna iterate through. We're gonna create something called we're gonna call it indices, mapping in color index. All right, gonna be a default dict. So we need a default dict from collections port default dict. So default dict is going to be a list, right? I'm going to say for I, B in enumerate boxes. What I'm going to do is color index B dot append I, right? After we're done, when I go through, we are going to go through. Yeah, we're going to go through the entire thing. So we're going to say for key value in enumerate, no, in color index what dot items, right? And we say if len v is equal to 1. Actually, they can be combined. We say if v0 plus len v is equal to v this. Let's see if it's correct. V0 is the first index plus the length. Actually, it should be plus the length minus 1. Plus the length minus 1. That will be the last index, right? Let's say V0 anything. Length is 1 and the last one. So if they're the same, or we have 2, right? With 2, and then that's going to be plus 1. Yeah, if that's the same, that means all of the colors are already continuous. Now in that case, we're gonna have a res, right? We're gonna have a res, because 0, not res. Call them a score, right? So score gonna be plus equal to a len v times len v, right? And after we do that, we're gonna have to turn all of them into zeros. But we can just remove. It's only 100, right? We can just remove. That's short. How do we remove? I actually do not know. It's very embarrassing. I don't know. How do you remove? A dot remove. Oh yeah, remove what position? 0. List dot remove x. No, remove the value. I don't want to remove the value, so it's a del a 1. It's delete. So if this equals this, we'll increment the score, and for j in v, yeah, for j in v, del boxes j, right? So just remove them. We don't care. We remove them. Now after we remove and Now we're done. Then we need to do this one more time, right? So what are we gonna do? What are we going to do? Yes, please. What we're going to do is we need a flag, right? We can call it initial length. Init length equals lamb boxes, right? And then we say while true, right? Let's do while true. We're gonna do this, right? And then we say if lamb boxes, because we deleted boxes, right? So we say if lamb boxes, the current length is the same as the initial length. I probably have to do this here. That's the initial length. And then we go through this and we remove, and after we're done, we check the current length and the initial length. If they're the same, then we break. That means we did not do anything, right? We did not do anything. If they're not the same, that means something gets removed. Then we can check again, right? We check again, and then we do this again. We try this again, and then if it's the same, that means nothing gets removed. Then we break. Now, after we break out, what we need to do is we find the longest, right? We find the longest. How do we find the longest? This makes me want to. You're saying we need to use a priority queue for this? Can you always keep track? I mean, we can, right? We can. I mean, all we need is to find the longest. Yeah, we just need to find the longest, right? We just need to find the longest. So, as we go through, I need, actually, this should be, there should be while lamb boxes. Because if we remove everything, we just break out. And we shall have, here is going to be, no, not here. It's every time we do, right, we have also the target, right, the target, I was just to say the longest, the max count, right, max count color equals, I don't know, what's the max count color? Max count color equals 0. It doesn't matter. And then we should have max count color and max count, right? Max count color and max count. Max count is a 0, right? 0 and a 0. So it goes through. So first of all, we're gonna say if it's the same, then we don't do it. Else, we would do. If it's not the same, then we need to keep counting. Then we say if len v is larger, what if they're equal? Good question. What if they're equal? Dang it. What if they're equal? My word. We only consider when they're different, right? We say when they're different, when they're equal, well, we have to go two paths down. If they are equal, if we want to combine 3, we take, let's calculate this. If we want to combine 3, we take 1, 4 plus the 3 combined is going to be 16, right? And the 4 combined will be 9. That gives us 26. No. 20. Yeah. 26. If we want to combine 4, so we take 3 out. We'll combine all 4. Then combine 4. Then these 3's will be out. Yeah, these 3's will be out. And then this 4 cannot be out, so it's just like a barrier. There's an individual, right? We just use force as a demarcation, so we're going to take this out and then take this out, right? And I take this out, it's going to be a 9. Take this out, it's going to be a 1. And the remaining is 16. Ah! ¡Qué sorpresa! It's the same value. Is this the rule, or is it just a coincidence? I mean, it is the same in the other situations I can think of. In any situations, right? Any situations. Because this one, I remove 3, I remove 1. And if I want to combine 3, I remove 1. And they are already together, and then remove 3. They are the same. So the definite B situation, that's going to be different. Let's jam it in more. Let's say we put another 4 just somewhere here. All right, this is slightly different. So if we want to get 4, right, want to get 4, then let's say we have all the 3's come out. So that's 4 plus 1 plus 1 plus 16, right? If we want to get 3 together, that is going to be, if we want to get 3 together, we go 1 plus 1 plus 4 plus 16 plus, that's the same. Both is the same. That doesn't feel like a coincidence to me. Let me think again. So we have some type of mixture, right? Some type of mixture. And if we want to take so some value, right? So the 2 are the same. And if we want to combine one of them, so the rest in between, okay, they're going to score something. And then we have something on the outside. I don't know, man. I mean, worst case scenario, if they're the same, we just run it twice. What if you have more than 2 that's the same? No matter how many, we run that many times, and then we pick the longest one, pick the largest one. Okay, so what we're saying is, if we have a longest one, and we pick that, and then we throw the remaining. If we have the longest one, now if we don't, and they have the same length, what if they have the same length? And we try to combine one of the lengths and the other length. Try to combine one length and we have to remove all the others, no matter how they scattered. Are you saying the pattern of scattering is the same for both? Well, it's not really the same. It's not really the same, but eventually the other one will all combine together. So the pattern of scattering, if I am all ones, you will be all ones. Not necessarily. If I'm all ones, take the 4 out. Yeah, the thing is, if we take the 4 out, we won't wait, right? We will take these two 4 out first, and then we can combine already, right? That's the thing. We can combine already, and then the last 4 is yeah, it's a different. How about right now we just say, we just pick one, doesn't matter. I feel like it might matter though, honestly. I feel like it might matter. So if it might matter, we have to sort, right? There's no other way, we have to sort. We have to sort. We have to sort based on the length, right? And then for the top, each one will split out into a different branch. Yeah, I don't see how. Yeah, let's do that. Let's do that. I can't have a good argument. All right, so in that case, it's not gonna be 1. I feel like I'm abusing the fact that the length is 100. So we still do all this, right? But there's no else. We still do all this. And we break, and there are mixtures, right? The mixtures. And then we need to sort. We need to sort the color index, the last color index, based on the keys, right? The colors, right? The colors. So we're gonna say sorted colors, right? Equal to sorted sorted color index key equals to lambda. No, not lambda. Key equals to no, I think it's sorted dot keys, and then key equal to color. No, lambda k color index k and length. Yeah, I think this is. So we sort the colors, right? And then for each one has the same, we have to do the thing. But then when we call remove boxes again, it has to be that, oh, we actually breaking them into smaller chunks. Yeah, we're breaking them into smaller chunks, like in between. Oof. Yeah, actually, I haven't thought it through. Have not thought it through. Broke them into smaller chunks. So in this case, if we want to combine 4, we're gonna break into 3, 3. That's one chunk. 3, that's one chunk. and 3, that's another chunk. So we need to get all the values, all the indices, right? And then we check the next index. And then we pass in a single one. Okay, so max count is going to be sorted colors, color index, sorted colors, 0, right? And then length. And say for C in sorted colors, right? C in sorted colors, O reverse, if it's true. So C in sorted colors, if length color index C is smaller than max count, then we break. Otherwise, so we have a score. Otherwise, so max count is going to be this, and then we call it next score, right? Next score is 0. And then what I'm going to do is we have the current color, right? Current color. Current color of max count. Yeah, current color. Current color. And we're going to go through current color, and everything is in between the current color is going to be taken out and compute, taken out and compute. And this whole thing, I feel like we're going to recompute a lot of things. And list is not hashable. We need to hash it, so we don't have to recompute the same situations. But why will we recompute the same situations? I don't think we will recompute the same situations. Let's just try it, right? So we find the max length, right? We find the max length. The C color C has the max length. And then with color C, we need to find, we need to split it up, right? Split it up. How do we split up? So we need to iterate through. It's color index, right? So we say for I, right? I index in enumerate color. I don't like it. For I in range color index C minus 1, which is len color index C minus 1, index and we say if color index C I plus 1 is larger than, oh no, don't know, continuous, gotta be a better way to find continuous. Let's say I is 0, all right? And then next one is we just keep going, keep going, keep going until it's not, and then we have the range. This is the range. Oh, it's fine. So if this is equal to, then what do we need? The 2 pointers, right? So 1 pointer is walk, 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 walk until we find one, right? Then I want to find a gap. That's what I want. I want to find a gap. How do we find a gap? So we walk from the front, right? And if it's same, just keep going, keep going, keep going until the next one is not. Yeah, I think it's fine. So we just say I equals 0, right? Say while I is smaller than this. Okay, while I is smaller than yeah, and we say if color index C I plus 1 is equal to color index Ci, that means they're continuous, then I plus equal 1. Else, now this is when they're not the same, right? So else is the net I plus 1, the index I plus 1, is not equal to the I. And now we have a gap. Right? So this is the gap that we need to do, which means what we're going to do is we're going to call next score. Oh my god. We need a temp score. We need a temp. Temp equal to 0. Yeah, and then else temp plus equal to self dot remove boxes, right? So we pinch it out, which is current boxes from color index C. It's I plus 1 I, right? Plus 1 all the way to color index C and I plus 1. Right, this is the gap in between. So we get that, and after we get that, I plus 1, so I need to plus equal to 1 as well, because we find the score, then we go to the next one, right? And then we check again, right? We check again, check the next one. If it's equal to, then we keep equal to, we keep moving. If it's not equal to, so which means this one we just can do is not equal to, and then we do this, and we always do this, which means we can do a for loop for I in range, right, in range to this, and we say if the next one is not the same, then we do this, temp, blah, blah, blah. And after we're done, next score equals max, next score, and temp. Right, so we run through, now we don't have to have I equals 0. So we run through sorted order and until we finish the max count, right? So we finish the max count, then that's it. That's the next score, which we take the maximum of everyone, and we're going to return score plus next score. All right, we put together a solution. Let's see. I'm not sure. Well, what I know is among the test cases, this is going to be correct. All right, this will be correct. I'm very confident. This will be correct. I'm very confident. The first one will be correct as well because the first one is an easy case. They gave us an easy case, easy test case. The real messy ones we have not encountered yet. 23. I believe we will pass this one as well. And boxes. Remove boxes. Boxes. Oh. That is weird. Oh, shoot. That is correct. We cannot remove it. Because as we remove it, the box shrinks size. This is not good. So we have to do boxes j equals 0. And then, when we're done, we have to redo boxes. Right? We have to redo boxes equals b. I've used b. No, I can't use b. For b in boxes, if b. Then that's how we shrink it. Because we cannot just shrink. Yeah, we have to turn it into 0. And then we run it again to shrink the size of the box. Local variable color index referenced before. That is not good. Well, we have color index. We should have another thing, which is check if not boxes, which we have removed everything, then we just return score. Yeah. So all three will finish by here, right? And the real difficulty is these gaboons. These are the real difficulties. So for these gaboons, we are going to do. Let me check. Let's see if this one can handle. This one can handle. This one cannot handle. What the heck? All right, we have found our issues already. What the heck? This one give us 22. My answer is 6. What? We know these pass and this one does not pass. So we will do, let's say sorted colors, max count. Sorted colors are 4, 3. Max count is 4, which is correct. So we say for C in sorted. This is a C in sorted colors. Yeah. So C will be 4. So we don't break, right? Temp 0. We know this one's correct. And for I in range, let's see. Print C and actually I want to print boxes. I want to print color index. We're gonna print color index, and then we're gonna print the current color, right? And color index this. And this, right? And this is what we want to see if it's correct. So 4 is this, 3 is this. So we do 4. Now we pluck out 3, 3, which is correct. And then we do 3 and 3, yes. And then oh, we forgot to, I think I know where we got wrong. I forgot to add the last part. Yeah. So for C, in order, so we check the max count, right? And then we get next score. So it'll be score plus next score is whatever the other score, and then we combine. I forgot to add a combine. Combine is going to be max count squared. There we go. Now we pass. Everyone will pass. I think that's just the only line that's different. I just forgot to add the last part. Now is the funny thing, right? So we're gonna just push in some 1s, some 2s, some random stuff. Just make sure we have no 4s, 5s, right? 5s, 6. Right, we'll do some 7. Right, we'll put another 7 at the end. And then let's do some 8. I'll put an 8 in between. Put like a 9. Okay. Let's see. It's a very complicated one. Nah. Nah, it's not correct. It's not correct. I think I should reduce it. So remove some. This one is correct. What did we do? This one should. This one maybe. No, this one shouldn't. This one should be right. 7 and 7 is continuous. Yeah, it's continuous. It's 1 and 7. That's the one. Which means I can remove all the single ones. The single ones are not gonna help our case. And then this is going to be, this is not going to help our case. Right? 9 is by itself. Why do I even do that? 9 is by itself. Awesome. 5 is by itself. That's not going to help us. 6. Oh, 5 is actually not by itself. 5 we might use 5. 1 is by itself. We're not needing 1. 54 is by itself. We're not needing 54. All right. 6 is by itself, right? We don't now need 6. Remaining has repetition. 33. We don't need 33. No, we don't need 33. 1, 2, 3, 4. 1, 2, 3, 4. 5, 5. 7, 7, 7. Yep. Let's try this one. Yep. Yep. Okay, let's see. Let's remove. So the only thing is 5. Let's remove 5. Let's see. Remove the 5. We still have problem. Yep, we still have problem. Okay, so in this case, what I think is we just don't break. Don't break. We try every single one. I don't know the runtime. Yeah, we just try every single one. And if we are going to time out, then it's time out. Oh my god. It's gonna be so bad. Anyway, we can actually. All right, let's do this. Do we dare? Are we there? Pending. Ah, we got a wrong answer immediately. Let's see how many we pass. Oh, we passed half. We passed half the test case. All right, so this one does not pass. Okay. Okie dokie. Should be 16. Oh, my output is more. That is interesting, to say the least. Anyway, we're removing this. Oh, the max count. Of course it's not going to be correct. We no longer do the max count. Ay, ay, ay. Hold. Next score equals this, right? And then, no, temp, after we get the temp, that's not correct. Next score equals, next is going to be temp plus the count, the color, the len, color index, C, right? That's the current count. Right, this thing time 2. That is, so we don't need max count. Max count is not defined. We don't need max count here. Just the next score. Ah, what the hell? Now we become 14. Oh, this is frustrating. So let's think again. What are we doing here? Right, what are we doing here? We're trying to combine any remaining, right? Any remaining want to combine them together. That means we should not combine. Does that mean we should not combine? Anyway, let's print current score and we print color index. We're not going to do all these, so we pass them out. The last one. Right, current score is 3, right? So what we have is 10 as at 0 and 4 position. So 10, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. 1 as at this 5 position, 3 as here, and 6 positions. All right. So this is what we have. 10, 1, 1, 3, 10, 1, 3. Right. That's basically we're saying we got it wrong. And okay, so we say we want to combine. I mean, in this case, we don't have the sort. We just try to find the next score, right? We don't have the sort. Sorted colors. Nah, it's just going to be for C in color index. Color index.items, right? And C and V and color index.items. Temp is this, and then be len V -1. And then all the color C is going to be turn that into V, right? So V this and this V, and next score equals len V. Yep. Let's see. Let's see. What score can we get? Let's say we want to combine 1 together. Right? If we want to combine 1, we have to take 3 and 10. That's 2 plus 1 is 3. So that's 9. right? And plus the remaining 1 and 1. That gives us 10, that gives 13. 13 plus 3 is 16. Oh. Oh. Hold on. I think I see. I see the problem. The problem is when we take it away, yeah, we have the other values on the outside. That's why we're not doing. Okay, so let's do it again. So we're gonna iterate through everything, right? And then we're gonna combine them. After we combine them, that's the next score, right? So awesome. Hmm. Maybe we should still sort them though. We might time out. But yeah, I see the problem. The problem is when we get the values, right, and then the remaining has to. We have to compute the remainings. It didn't compute the remainings. God. I need to compute the remainings. Front and back, and everything else goes to. So, what do we say? This is to compute. We will recompute the things. We might time out, but let's worry about this later. Let's worry about the timeout later. So this is for a single color, right? For a single color, we're picking things out from the color itself, right? And then after we pick that out, we have the temp score. The temp score is, and now so let's not call it temp, right? I'm gonna say that's the inside. Let's call it inside score. It's not temp, it's inside score. So we compute the inside score. After we compute the inside score, I don't like to call it inside score though. I'm just gonna call it. What are we gonna call it? Jeez. We're gonna call it. Yeah, temp seems to be the most appropriate. Let's call it temp, right? So this is a temp. Temp is going, and then temp plus equal to this lambda. Right, so this is the total score we can get by combining the color, the current color. But by combining it, that's all we can get, right? And after that, after we combining this, we need to also look at the remainings, right? Mind you, we need to look at the remainings. How do we look at the remainings? We need to go inside V, right? So we're gonna say temp plus equal to this plus self dot remove boxes to v0, that's front and the back, and plus self dot remove boxes, this is going to be v minus 1, v minus 1, last index, plus 1, right? So that's the front and the back, and that's our temp. And after we get a temp, let's get like the current color combining, and this is going to be temp, the next score. And if we do this, we will pass. However, I'm pretty sure this is slow as hell, right? This is slow as hell. We can actually run the other test cases. I think they will all pass. Yeah, we'll all pass. But, my goodness, this I feel will be slow. Yeah. I want to generate a test case of 100 numbers. All right, let's generate a test case. Just I want to check from random import randint, and we're gonna say randint 1 to 100. I think that's the values 1 to 100 for this in range 100. Yeah, that's the.
Wait, hold on.
Can take it all. All right, so this is 100 values. Let's see how fast we go. Probably fast because 100. It's not correct. What? Oh my god. Even with all this is ridiculous. How? It takes a long time and then it's not even correct. Alright, I don't know. Take just delete some values. How is this not right? I'm considering every situation. Now you're telling me that the numbers are not supposed to be combined together. And then it changes everything. Lord. So these are correct. God. I hate this. How about the second half? The second half is correct. So something from the first half and something from the second half. I cannot even. How do I know which part? So we know this part is correct. Let's delete a smaller portion and then see how it goes. That one is correct as well. So we have to delete 2 rows. Oh yeah, trying to find where the bug is. Oh, yeah, it's also correct. Something in the last row. Uh-oh, that's not correct. Let's delete half of it. Trying to pin down the. We can keep deleting. Let's leave 51. For whatever reason, I feel like 51 is the culprit. Yep. If I delete 51, I think I'll be. It might be correct if I delete 51. Yep, that's 51. Right? And now we have 51, and we can remove all the unique values. Okay, so Ah, man, you just sorted for me. No, no, that's not what I want. No, that's not what I want. I want to remove the unique values. So I think we need to call counter. I'm trying to bring it down. So we're gonna call counter on A. Then remove all the values. So we're gonna get call turn. So for KV in counter A, items, and let's say K, if K equals, if V equals 1. Alright, so I'm going to remove all these. 55, we can remove, actually do this. So we can do this. I'm going to say for A, now for B in this, A dot remove B. Alright, so this is remaining. This is the remaining values. This is the remaining that will still give us trouble, but this is much smaller. Yeah, and we have issues with this. So what do? Let's gut it a little bit more. Let's gut the middle row. Let's see what's going to happen. Yeah, we still have a problem. That's good. Let's gut this one, but don't affect 51. So what's going to happen? Yep, we still have a problem. Now let's gut these. But we shouldn't. Let's gut these. Now we correct, so we got it too much. Let's gut the front. Yep, still do. And then if we still do, also gut all the values. And then this is single. We can gut it. 4 is single. We can gut it. I see 78, 83, 28, 67, 78, 51, 26, and got 26. And got 20, 17 as well. We can get 34, so they are continuous. Well, let's try this. This shall still be wrong. Oh. So what else can we cut? 38. I don't see 138. 38 can be cut. 67, 78, 83, 28. Okay, so this is what we are left. Okay, so it's good. We can do this. I'm gonna turn them into different numbers. 1, so 51 will be 1. 28 will be 2. 83 will be 3. 78 is 4. This will be 5. Wait, 78 is 5? No. Oh, 78 is 4. This is 5. Alright. Yep, so we have is 1, 2, 3, 4, 5. 1, 4, 5, 4, 3, 2, 1. So 1, 2, 3, 4, 5. 4, 5, 4, 3, 2, 1. and 1, 4 in the middle. Which I'm pretty sure if I remove the 4, it will still be wrong. Yep. If I remove the 1, I don't know. That would be correct, which means, what if I remove this? We're seeing a pattern, right? That's what we see a pattern. That's correct, which means I need 2, like this. Right? 1, 2, 3, 4, 4, 3, 2, 1, and actually 5. Let's say maybe 1, 3. Right? We'll put 1, 3 in the middle. Yeah. Which means we can remove this. Put 1, 2 in the middle. Yeah. No, that is correct. So we cannot put 1 and 2 in the middle. So we have to go back to, no, 3. No, wait. So 1, 2, 3, 4. 1, 2, 3, 4. Oh, yeah, I think this is the one. This is the simplified version. Yeah, so 1, 2, 3, 4. 3, 1. 3, 1. And 4, 3, 2, 1. Okay. What we're saying is we are going to combine. So the answer is 20. How do you get 20? Let's see how you get 20. So we have 3. So my way of getting 20 is we get all the 3 together. So we're going to remove, so to get all the 3's together, we have to remove 4 and a 1, 4, which will cost us 1 plus 1 plus 1, right? Which costs us 3. And give us 3. So 3 together will give us 9. After that, so we remove this already. Oh, we do the front and do the back separately. No, you shouldn't do that. You shouldn't do that. You should do them, combine them together. Now you do them separately. The front will be 2. The back will be 2. That gives us 16. Whatever, that gives us something bad. But if we combine them, we're going to plus 4, which will give us 12 plus 4 is 16. We're 20. Yes. So I see the problem. I see the problem. So the problem is not is not doing it 2 times. It is combine them. How did I not think about this? It is to combine them. Right? And then this is our test case. Answer is 20. Right? Boom. This one's correct. Okay. One more time. One more time. One more time. Where's our giant test case initially? This is the giant test case initially. We simplified it down. I'm going to try it again. Try this one more time, but better still. We're going to do it again. Yeah. And where is it? This one. Okay. See if I can select. I don't know. I cannot select. Select. I don't want to select all. I only want to select this. Okay, I cannot select when I'm in PT Python. Very unfortunate. All right, so this is another one. Let's see. Ew, that's so slow. Oh my. Are we on timeout? Oh, jeez. 9 seconds. We need to cache. I mean, we have to cache. There's no way. There's no way we have to cache. We have to cache. Okay, so doing it here for caching. Yeah, no way. I mean, caching gonna look ugly, but it's the only way out. Otherwise, I mean, this is gonna take a long time. If I run it, see, it just hangs because we did not cache. Let's see. From functools import. Where are you cache? Right. So we're gonna cache this. Where are you cache? None. But this is a list when it passed in. So what we're gonna do is not caching this. And it's like def helper. Boxes. When I'm passing, this is gonna be a tuple. Because tuple we can hash. So we're passing a tuple and return an int. And this thing can be hashed. So I'm going to put it here. Everyone is going to hash. So this is the same. Next scroll, blah, 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 self dot. Now we're not going to do remove boxes. It's going to be helper. So both going to call helper. And this, my friend, is going to be a tuple. We are going to put them as a tuple. Right? And this is going to be a tuple. Yep. And I'm going to call it what? Call helper tuple boxes return helper. And there's no self. So tuple is, this is not going to be self, just plus this. Alright, let's see if it's going to be any faster. Tuple does not support item assignment. This equals list boxes. Okay. Yup. See that? We go from 9,000 milliseconds down to 148 milliseconds. Alright. Come on. Let's do one more. One more random case. Alright, it's the last random case. If this one pass with good enough time, we're going to call it 342. Alright, let's try it. Submit. Pending. Judging. Come on. Come on. Oh yes, I think we redeemed last week. We passed. We passed. Oh, with flying colors. We did pretty good. We did pretty well. They might actually accept the original with 9,000 milliseconds, but we got 77% ranking. Oh wow. It's pretty tough, but I'm proud of myself. So I'm not sure. I mean, the ideal of using the I don't know. Honestly, I have no idea. Our memory usage might be very bad. Oh, the memory usage is not that bad either. Wow, this is a good solution. It's not that long, and it makes perfect sense to me. I mean, the only trick we do is turn them into tuple, so we can cache them. and we don't sort. Yeah, I mean we can, but it's good enough. It's good enough. All right, let's write summary, and we have redeemed ourselves from the slump of last weekend. So how should I say? The first intuition, not intuition, insight, is that if we have colors that are already, if we have a color, if we have a color with all its boxes already in a continuous, consecutive, already arranged consecutively, with all its boxes already arranged consecutively, they can be removed immediately. Deterministically, it can be removed deterministically. After they are removed, the arrangement of the boxes changes, and we can try it again. We can try removing the consecutive boxes again until we cannot anymore. Then we are left with a list of boxes with repeated colors that are also intertwining with each other, right? Since it is always better to remove the same color, to remove the boxes of the same color after they are combined into a consecutive arrangement. This can be proved mathematically. We will combine all the colors that are left. And we'll combine each color that is left, right? We'll combine each color that is left and see what score we can get, right? And we use recursion. We use recursion to handle this part. For any color to combine, we recursively compute the max score from removing all the other boxes jammed in between, right? Jammed in between. And then we compute the max score from removing the rest of the boxes after the target color is removed. Yeah, we do this for all colors and pick the largest score. Yeah, pick the largest score as our result. In order to speed up the computation, we use caching. Since our input is a list, we have to turn it into a tuple for caching purpose. Yeah, we have to turn it into a tuple for caching purpose before before recursive calling, before recursive calls. And I don't know the runtime. I mean, it takes, I don't know, it takes on, I think. It takes on to do this. And this is just, I do not know. I mean, we combine this, and then we do this. Maybe on squared. I don't know. Maybe on squared. I do not know the runtime. But the total, do not know the time complexity. But okay, so the worst situation is each combination will be computed, right? Each combination will be computed. So the total combinations, that's the high, I know the high bound, right? The high bound is just the total number of combinations. But we're not going to hit the total number of combinations because some is just not going to be possible. I'm going to take on to remove it's on squared. Yeah, I think it's take on. We take on squared, right, to remove all the things that can be removed initially, and when we do recursive call, it's like what n, like log n, on squared log n, maybe. Runtime is 940 milliseconds, or we hit a very good 77% ranking. Let's put some comments. All right, so this is remove all deterministic, all consecutive. Remove boxes that are remove boxes that are arranged consecutively. That all of them, boxes that all of them are arranged consecutively, right? And then no box which is returned. So here is we'll combine each color. Combine each color and then compute what score can we get, and pick the highest score among them. And then we use, like, this is within, we do this, right? After we do this, and this is the outside. Okay, let's see if we have solution. Probably not. Nope. But it's fine. Number 546. Okay. Number 546. What is the good solution for this? That's a good question. I like it. Top down. 5 lines. Oh, how many lines do I have? 35 to 67. What? 23 lines. 33 lines. 33 lines. They solve in 5. All right, let's take a look. Oh man, look at this. Oh, nice. Nice and simple. On to the 4th. Fast DP. Yeah, I think he is taking over the other guy. The other guy don't have pictures. He has pictures. We all love pictures. All right, let's see. This is really a hard question. I mean, it's just with me, right? Sometimes okay hard questions that got me stuck. Sometimes this one, which he says is a real hard question, and then we got. Yeah, I think we got lucky. I don't know. I mean, this part is easy to identify. Right? This part is easy to identify. It's just this part. Let's see. DPLRK denote the maximum points we can get in boxes L to R if we have extra K boxes, which is the same color with box L in the left side. Oh my dear God. Let me read that again. Let DPLRK denote the maximum points we can get from left to right, if we have extra K boxes, which is the same color with boxes I in the left side, okay? So for this, DP 0, 1, 2, 3. 3, 4, 2 is the maximum points we can get in boxes 3 and 4 if we have extra 2 boxes, the same color as box 3. It's the same as we find maximum points in boxes equals this. That's true. Since this, it's better to greedily remove all contiguous boxes of same color. That's true, instead of splitting them. So we increase both L and K, while L plus 1 equals box L. If L plus 1, which is the next one, if the next one equals, so if the two boxes are the same color, then we increase L and we increase K. Yeah? There are many options to consider. Option 1, remove all boxes which have the same with box L. All boxes which has the same color with box L. Total points we can get is option 1, we remove all boxes which has the same with box L. Points we can get is L plus 1 to R with 0, and then K plus 1 times K left boxes, and Lth box have the same color. Are you seeing the K left boxes? So we say we do that. Why L plus 1? I don't know. Why do you do L plus 1? Remove all boxes which has the same. Oh, because we say if we have a continuous, right? So what we can do is we can combine everything on the left, which is K plus 1, and we're going to do L plus 1 to the maximum points there. Other options, we try to merge non-contiguous boxes of the same color together by finding the index j, where L plus 1, so that box j is equal to boxes L. Total points we can get is dp j to r and k plus 1 plus dp l plus 1 to j minus 1. And 0. L plus 1, j minus 1, and j to r, and k plus 1. Let's see. Not 100% sure. Okay, so we'll keep going until we cannot go no more. So we keep going until we cannot go no more. So I will not equal to, so yeah, so L is the last one of the same color. So once we have that, remove all boxes which has the same with, that is contiguous. That's true. So the front K is contiguous, gets K plus 1 actually, and then the remaining, all right? I'll remove, okay, I see what you're doing. Okay, I see what you're doing. So we say from the front, we have contiguous, we always remove them, right? That's what you're trying to say. If we have it, we always remove them. But then what? That's one way. That's one way to do it, right? One way to do it. And another way is from L plus 1 to R plus 1. So we're going inside the range, which is outside the contiguous, right? So from inside, what we do is, if any one we find is the same color as L, right? Same color as that one. So anyone we find the same color, when we find it, we can try to combine. How do we combine? So we have from, so this part is the color that has no color, right? No L color. This is no L color. This part is no L color. This is the first one. This is the one that we have the L color, and we say from M to the end to R, right? M to R, and then we have K plus 1. Yes, the previous one, and we want to find the max score of this. That is true, right? And the max score of the ones in the middle. And we compare which one is larger. And we keep going, right? We keep going. And as we keep going, all right, so the M gets larger. And yeah, this one is we don't care. Right? This one basically says we don't care about what, this is exact the same as when we start, right? This is just exact the same. And this one will always do K plus 1. Let's try this one again. So 2, 2, 2, answer 1 equals dp 380 plus, that's true, option 1. That's option 1. And all boxes which has the same way that this. Option 2 is we go find this, right? So it would be dp 683 plus 350, or 783. Yeah, so this one and this one. And remove this. So this we're making sure that we are combining. Yeah, so we are combining all of this. Hold on. Are we combining all of these? Yeah, we're combining all of this. If it is 683, right? We will start from here and we'll keep going. Yes, yes, yes. So we'll combining. So basically, we say we're gonna combine these three with these two, whatever, like with everything, or these three with one of them. These three with like just every single time we want to combine. Like combine all of them, like part of it, part of it, part of it, until we cannot combine no more. So we just keep going. That's the last one, and then this is a fresh, new computation. Oh wow. That is good to know. The DP states, because we have three, right? Three values. So enter the third. Each state needs a loop on to compute. So total n to the fourth. I don't know. Memo. No. All right, this is pretty good. You want to post your answer? Yeah, I want to post my answer. This is very different, and I'll try to write it myself. I understand how it is, and that's my thing. Python 3. How should I put it? I can't even think of a good name for my post. Let's call it. I'll remove deterministic boxes first, and then handle the what? Then handle the intertwines. And combining then combining colors. I'll be very honest that I do not know the runtime, but it is my effort. Yep. Let's just post it. The arrangement of boxes changed, and we can try to remove any concealment again until we cannot anymore. There's a box with repeated colors that are also intertwining with each other. Oh, an extra parentheses. Let's change that. Let's edit. I find an extra parentheses. I should have proofread it, right? Since it is always better to remove. Let's update. It's always better to remove the boxes of the same color after they are combined into a consecutive arrangement. We will combine each color that is left. I'll combine. Man, this doesn't read right. Let me redo it. First of all, we don't have to do this. We'll combine each color, and we'll combine each color by itself, right? Combine each color by itself, and see what score we can get to handle this part. Any color to combine will causally compute the max score from removing all the other boxes jammed in between, and then we compute the max score from removing the score after. after the target color is removed, the max score of the remaining boxes after the target color is removed. Do this for all colors and pick the largest score as our result. Yep, let's copy and paste again. It's fine. Let's edit this. Well, when I say edit, basically we'll just do it one more time. Update. Okay, so solution 2. Solution 1 and solution 2. Very smart and good explanation from here. So do this, copy this, but I don't want to see. I'm gonna try to write it myself. Yeah, like a hard question, a really hard question will probably have slightly higher pass rate because people gave up after a while and then they just go look for the solution. This one like 40-something%. It doesn't mean that people have good. It's easy to do. No, it's not. It's not. It's not easy. All right. So what do we do? Well, we have helper. Helper will have left, right, and k. It's gonna return an int, right? And we're gonna your cache none. So this is when we start. So what do? We are going to go through and then increment, right? I'm gonna say, what's the R doesn't, so if L is smaller than R, right? That's return 0. That's the edge case. And so while L is smaller than R, no, if L is larger than R. We can also have if L is equal to R. Yeah, that's probably can be handled here. Or L is smaller or equal to R. What we do is if boxes L plus 1 is equal to boxes L, right, consecutive, then L plus equal 1 and K plus equal 1. And this. Oh, we have to do smaller than R because L plus R could be, yep. So we do that. So this first round, now we get out. And then we say res going to equal to. So now L pointing to the last of the consecutive color. Now what we can do is K is the total number, right? And then L plus 1 is not equal to boxes L. Now we break out. And L is pointing here, right? So K, so it's going to be helper, right? L plus 1 is the next one to R with 0 plus K plus 1 times 2, not times 2, a square. And then for J, for I, in range L plus 1, right, all the way to R plus 1. So in this range, if boxes I is equal to boxes L, same color, right? If I same color, then we decide to we decide to combine them together, right? How do we decide to combine them together? So if it's the same, right? If I is the same, then we say we can remove the ones in the front, right? Res equal to max res, and we're going to remove the ones in the middle, which is helper, L plus 1. I remove the ones in the middle, L plus 1, and I. So I copy minus 1 and a 0, right? And plus helper. Yeah, this L plus 1 until I minus 1. This thing's in the middle. And helper I, right? To R with k plus 1. That's the total number in the front. Yeah, and then next time, if it's the same color, then we're going to do the same thing. We remove the middle, and we do the rest, and they probably all combine together, right? And because when we do helper this, and it's the same color, then we just increment in k, right? It's the same, just like we combine them together, right? So we do this, and then we return this. Right, and then we're going to return helper 0, lamp boxes minus 1, and 0. Let's see. Nice. Very, very smart. Very smart. And it's fine. I mean, it's the second time I run it. It usually happens. If you're a bit slower, but it's fine. Okay. Let's also see, what do you have? I think almost. I'm reading the last part. Is it the same solution? Give a substring, and we add a case symbols bi before the start. I think it's the same thing. Index bm equals b. This is we're not incrementing k though. So ijk, and then we go through from I plus 1 to j plus 1. If it's the same, we get all the get all the m out, and answer will be this plus this, yes. And then for m in each index, we do I plus 1, m minus 1, 0, which is it's the same thing. It's the exact same thing. exact same thing. The only difference is we simplified, so we don't do this, right? But we do this part, the increment part. We do the increment part right here. We don't increment manually, we increment by doing this. So I think we're saving calls in this solution. This one will call more times, but overall it's the same. Overall it's the same. Wow, this is. And he said it's the top 10 most difficult. How did you figure it out though? How did you figure out this DP solution though? I don't know. I don't know, but yeah, I'm gonna give upvote as well. This is a very good solution. Let's see. Most votes. 2017. This problem is 2017. All right, that's it for today. We actually solved it. Good effort. Good effort. I'll see you guys tomorrow for another difficult one. Adios.